Alright, in this problem we want to know, are two events independent? Okay, and independent means that knowing one thing has happened has no impact on the probability of something else happened. Okay, so we want to know, is the probability that someone is a Democrat, is Democrat independent of being liberal? Okay. All right, so just intuitively we can think about this. All right, and so if we know someone is liberal, is that going to change whether the probability that someone is a Democrat? If we think about it, the answer is yes. If we know someone's liberal, we're going to think that that person is more likely to be a Democrat. Okay, but we can test this to see if they are independent or not, and this helps us for situations where it's not so clear and obvious with things like political parties and ideologies. Okay, and so the key is that if A and B are independent, okay, then what's going to happen is that the probability of A is going to be, well, that's going to be the probability of A, but then the probability that A given B, okay, a lot of times we think that this is going to be the probability of A and B divided by the probability of B, okay? But if they are independent, only if they're independent, the probability of A given B is just going to turn out to be the probability of A, okay? Which means that the probability of A, whether B has happened or not, is just the same as the original probability of A, okay? And this is all. This is only true if independent. Okay, and again, how do we find the probability of A and B, or of A given B? Of A given B is just going to be the probability of A and B divided by the probability of B. So what we want to do is we want to calculate this number by solving this thing, and then we're going to compare it to the probability of A. Okay, so what we want to know is the probability of being a Democrat, given that someone is liberal, is this equal to the probability of just being a Democrat? If yes, then they are independent. If no, then they're not independent. So what's the probability of being a Democrat given that someone's liberal? Okay, so this is going to be the probability of being a Democrat and liberal divided by the probability of being liberal. That number turns out to be Democrat and liberal is going to be 306 divided by 1858 divided by being liberal 530 over 1858. We did this in the last problem. It's going to be 306 divided by 530, which ends up being 306 divided by 530, 0.577. And we want to know, is this equal to the probability of being a Democrat? Okay. So what's the probability of being a Democrat? That answer is we have 689 people who are Democrats out of 1858. So we're going to do 689 divided by 1858. So we do 689 divided by 1858. That answer turns out to be 0.371. Okay, so is 0.577 equal to 0.371? No. So that means the probability of being a Democrat, if we know someone's liberal, is not the same as the probability of being a Democrat. Okay, and that makes sense. All right. If we don't know anything about a person, what's the probability that that person's a Democrat? Something around 37%. If we know nothing about this person. Okay. But then as soon as we find out that that person has liberal ideologies, then the probability that that person is a Democrat increases, okay? Oh, so-and-so is liberal? Oh, he's probably going to be a Democrat. Okay, so the probability that someone's a Democrat all on its own is different from the probability that someone's a Democrat if we know that that person's liberal. So here, no, being Democrat and liberal are not independent. Okay, so being Democrat and being liberal are not independent.